Today we're going to review for our Unit 1 and Unit 2 test. We'll be going back and forth between the PDF that you have access to on Moodle and that you see now on the screen and to the Smart Notebook file that I'll be writing some of the solutions on. Let's start over on the Smart Notebook side with our first 4 questions. The questions will be in pretty much the same order on the test, and they follow the same order that you began to learn about them when you were going through your homework and your videos and readings. The first 4 are from Appendix A, and we're looking at absolute values equations, inequalities, and then some work with radicals. So for number 1, let's solve our absolute value equation. When you want to solve an absolute value equation, the first thing you want to do is isolate the absolute value bars. So what I'm going to do is subtract 14 from both sides, and I have negative absolute value of 8x equal to a negative 7. Then that negative out front is like a invisible negative 1, so I'll divide both sides by the negative 1. And so now I have the absolute value of 8x is equal to 7. For absolute values, you then need to split and switch. So it could be that it's equal to what you see, in which case x would be equal to 7/8. But it could also be equal to the opposite of what you see, so a negative 7, and it could be a negative 7/8. And so my solution for this is 7/8 and negative 7/8. For inequalities, we'll do the same thing, but we'll have that one extra step of having to flip the inequality symbol. First, I'm going to need to isolate the absolute value bars. And so I'm going to say absolute value of x plus 2, subtract the 9 from both sides, equal to a 4. And it could be that it's equal to what I see. I'm going to scoot this down a little bit. So x plus 2 is less than or equal to 4, but it could also be equal or less than to the opposite of what I see, which would be x plus 2, and then when you flip the sign, you have to flip the symbol, and so now this would be greater than or equal to. Solve both. I get x is less than or equal to a 2. X is greater than or equal to a negative 6, and if I think about this on my number line, here's my negative 6, and here's the 2. These are going to be brackets because of the x or equal to that's underneath them. And I need to be less than 2, but greater than the negative 6. And so my solution set is from negative 6 to 2 inclusive. Also in Appendix A are radicals, and so we're going to look at number 3 and number 4. For number 3, it says simplify the expression. In order to add or subtract radicals, we need the radicand, the piece that's underneath the radical, to be the same. And so I'm going to split each one of these pieces of the terms into their own radical. So I can do a sort of prime factorization. We're going to want to simplify the numbers into factors where 1 is a perfect square. Now I have a radical 5 that can't be simplified any further, so he's going to have to stay the square root of 5. But if you remember your little trick, you have an index out here of a 2. And 2 goes into 2 once with a remainder of 0. The one that you divided into for the first, that is your exponent on the outside, and then your remainder is the exponent on the inside, and if it's a 0, then you don't have an inside. So this, the square root of x squared, is just an x. Next is 125, and so if I think about factors of 125 where 1 is a perfect square, that is a 25 times a 5, and of course we know the square root of 25 is 5. Radical 5 will have to stay as it is, and we already figured out the square root of x squared is x. And we've already done both of these in the previous parts of this expression, so we can just go ahead and copy those from before. Now I'll say outside with outside and inside with inside. So this just has an outside and an inside. So how about x times the square root of 5? This will be 35 because 7 and 5 are both on the outside. X times the square root of 5 And then I have 3 times 5, which is 15, times another x over here, times the square root of 5. And now we can see that these two pieces match. Actually, they all match. Here we go, square root of 5. I have 1x plus 35 x's, so that's 36 x's, plus 15 more. So how about 51x square root of 5? And now he's simplified. We'll also have to rationalize a denominator. And so I have for number 4, 2 over 8 minus a radical 3. And I'm going to scroll down a little bit and make some more space. 2 over 8 minus the square root of 3. When you're rationalizing a denominator, that means just get all of the radicals out of the denominator. And when it's a binomial, what you'll have to do is multiply by the conjugate. And so the conjugate here will be 8 plus a radical 3, and we'll do that in both the numerator and the denominator. My numerator, I'll distribute the 2. I get 16 plus 2 square root of 3. Down here, the reason we choose the conjugate is so that way my outer and my inner pieces will add out, and I'm just left with my first 2 terms multiplied together and my last 2 terms multiplied together. And the square root of 9, of course, is just the 3. And so this can simplify to 16 plus a 2 radical 3 over 61, and unfortunately that's as good as it's going to get. For the next few, we're going to go back to the PDF. Number 5 says, tell me if it's a function or not. And if it is a function, tell me the domain and the range. This is indeed a function because each x value only goes to one y value. In fact, this is called a one-to-one function, which will be important in a couple more sections. My domain values are the set of all x's, such that x is equal to a 4, 9, 14, 19. Or you can just say domain 4, 9, 14, 19. My range values are the set of all y's, such that y is equal to 20, 45, 70, and 95. Number 6, use the graph to find where f is 4. So when x is 4, what is y? Well, here's 1, 2, 3, 4. And if I go up, looks like I'm at a 2. And so, oh, I wrote 2. I meant to write a question mark, and I wrote the answer. And so my y value is 2, so f of 4 is 2. For what numbers x is f of x less than 0? So f of x is the function. You want to think about where is this under 0? Where is it under the x-axis? Well, from here to here, right? This whole section. But don't include the 0. I want to know, this is where it starts. That's where at a -3, but it's not an or equal to. So you can't include it. That's why I have to have the open parentheses. And it stays under until I hit 1, 2, 3, and that certainly looks like a 3.5. And so I'll put 3.5, and again, open parentheses because it doesn't say include. It doesn't say include. Tell me where the function is increasing, decreasing, and is constant. So let's start with increasing. I am increasing here only, right? And so I'm going to be increasing from the -1 to the +1. Now let's look at decreasing. I am decreasing in this section, and actually in this section. So we are going to be decreasing from the -3 to the -2. Again, from the 2 to the 4. I think that it's fine to go ahead and write it like that. Now let's talk about constant. I'm constant in this section and in this section. So my function is going to remain constant from -2 to the -1, and then again from 1 to 2. So I have those different sections. Number 9, I have a piecewise function. Capital F of x is, we're going to say we get this graph by taking, we're going to get our next graph by taking this and then saying f of x plus 2, then minus the 1. So we'll have to remember what each part of this graph does. This minus 1 out here brings my function up or down the way that you would think. The piece inside goes left or right the opposite way that you would think. So if it says plus 2, it's actually going to go to the right 2. So if I'm at a -1 here, I'm actually going to go this way over to the -3. And then this -1 says from here, now go down 1 to here. And so this -1, 1 will come over here to -3, 0. -3, -2 is going to go 2 over to the right, so to the -5, and then down 1. And so we'll be here at -5, -3. And you can kind of see your pattern, right? So I'm going to take my x part of my coordinate and subtract 2. So I'm going to come over here to the 1 for the 3, -4, and then go down 1. For my y part of my coordinate, and then I could just go ahead and connect the dots. And the red version of my graph is f of x plus 2 minus 1. For 10 to 13, and actually 14, we'll go back to the Smart Notebook. Now we're starting to look at Unit 2, where we're going to start looking at lines and then also solving systems. Find the equation of the line that has the points -8, 3 and -7, 2, and write it in slope-intercept form. So slope-intercept form is y equals mx plus b. And if I'm looking for the equation of a line, I need a slope and I need at least 1 point so that I can find my b value. If you're given 2 points, you'll need your slope formula, which is in your change in your y values over the change in my x values. So for number 10, first thing I'm going to have to do is find the slope. I'm going to make him my x1, y1, and this my x2, y2. So -2 minus a 3 over -7 minus a -8, which will give me a -5 over a 1. And so I get a nice slope of a -5. Then I'll pick my favorite point. I'm going to use the second one and use y equals mx plus b and find the rest of this. Y is a -2, m I found to be a -5, x is a -7, and now all I have to do is find b. -5 times -7 is 35. And when I subtract that over, I get b is a -37. And so the equation of the line for number 10 is going to be y equals -5x minus 37. We're going to do the same thing for 11 and 12 for parallel and perpendicular, but they give you a little bit of a hint in that we're not going to have to do much work to find our slope. They gave us the point and a line. And so you have to remember that parallel lines have slopes that are the same, and perpendicular lines have slopes that are negative reciprocals. I'm going to erase number 10. So if I want to talk about a line parallel to the 4x plus 7 equal to a -2, the first thing I'm going to have to do is put it into my y equals mx plus b form, because the coefficient of x is only the slope when it is in slope-intercept form. So first I'm going to do, I'm going to subtract that 4x to the other side. So I have -4x minus 2. And then I'm going to divide everybody by the 7. And so that line in slope-intercept form is y equals a -4/7 x minus a 2/7. So kind of an ugly b, but we really don't need that. We only need our slope. Take your slope and your point, which is 3, 3. and plug all of your information into y equals mx plus b to find our new b. Y and x are both a 3, so now I have 3 equal to, well, negative 4 times a 3 is a negative 12 times 7 plus b. And I'm going to add that over to the other side, and I'm going to go ahead and use my calculator. And so I have 3 plus 12 over 7, which is not a nice number, but if I hit math, enter, enter, I get 33 over 7, and so b is 33 over 7. And so the equation for number 11 would be y equals negative 4/7 x plus 33 over 7. Not too bad. A little bit easier for number 12 in that they already gave you the line in the right form, so then all you need to do is remember what a negative reciprocal is. The perpendicular slope flips your slope upside down, so if it was a 2 over 1, it's now 1 over 2, and then swaps the sign. It was positive, so now it's negative. And so for number 12, my perpendicular slope is a negative 1/2. Do the same thing we did in 10 and 11. Use y equals mx plus b. Y is a negative 2. M is a negative 1/2. X is a 1. Let's find b. So I have a negative 2 equal to a negative 1/2 plus b. Add that over, and I get a negative 3/2, and you can use your calculator to give you a hand. And so the equation of this line will be a negative 1/2 x minus a 3/2. These new denominators don't always have to be the same number. They can be different. It certainly depends on what your numerator is and if you can simplify at all. Number 13, and I'm going to erase 10, 11, and 12. It says regrind. Regrinds use typewriter platens. And the variable cost of each platen, I believe it was a platen, it might have been platen, is $1.30. And if the total cost to regrind 60 of these is $400, now if I were to reground these and sell them for $9.40 each, how many must be reground in order to break even? And so I have a couple of things I need to do here. It costs me $1.30 to regrind each platen. Now that's the variable cost. What's a little sneaky is they don't tell you the constant cost. So I'm going to put that in as B, and that's Y. I know if I regrind 60 of these, it's going to cost me $400. So I can find that fixed cost. So this might be like the cost of buying the machine that does the grounding. $1.30 times 60 is 78, and 400 minus 78 gives me a B of 322. And so the cost to grind each platen, I'm going to say C of X, is $1.30 X plus $322. I'm going to sell each one of these for $9.40. So a little bit more about the costs. So this maybe was the cost of the machine that I have to buy, or maybe my rent for the month, or it could be a combination of a couple of different things. This could be like the person that you maybe have to pay, hopefully not $1.30 an hour, to regrind them, or maybe it's electricity. And so the more plates you regrind, this is always going to keep going up, but this remains static. So if you only ever regrounded one, it was a very expensive typewriter. But if you did like 1,000, this is going to be pretty negligible, and that it gets divided up however many you have. We're going to, for whatever reason, talk about what if I didn't make any money, but I didn't lose any money either. So let's say you go into business and then you decide you have to get out. How many platens or platens would I have to regrind and sell for $9.40 if I was going to break even, so I didn't lose any money, but I didn't make any either? And so my revenue is $9.40 for each one that I sold. Same number, right? Because for every one I make, I'm hoping to sell them. So where are these the same? Where will these two things intersect? So you can either solve the system by graphing, or you can solve the one-step, or in this case, two-step equation. And then I'm going to have to subtract this $1.30 over to the other side. So I get a $8.10. And I want to know 322 divided by 810. Oops, I put 822. 322 divided by $8.10. 39 and 0.75. Certainly can't sell 0.75 of a platen or a platen or whatever it is called. So we are going to have to sell 40. And that's going to be my break-even point. Number 14, I kind of prepped the calculator and also the scatter plot a little bit. You're given 12 different temperatures and latitudes, and you want to make a scatter plot. And then you want to talk about a line of best fit. And so when we're done, our line of best fit and our scatter plot will look something like this. And I'll show you how to do this by hand and also with the aid of your calculator. And so I'm going to scroll back up so that you can see the rest of the question. Okay. So now I have almost all of my points plotted. I left the last or the first two for us to graph, 30 and 59. So we go to 30 on the X and then up to 59, so right about here. And then 47 to about 57, and so you get something that looks like this. So not a really good graph, right? So what we could do instead to give us a little bit of a break is to go into Stat, Edit, and put all my temperatures in L1 and all of my latitudes in L2. Go up to Second Stat Plot, hit Enter, Enter to turn it on. Now when you hit Graph, you're probably not going to see anything. So we'll need to hit Zoom and then go down to Zoom Stat or Z-Stat. And there we go, much better. So now we're going to talk about a line of best fit. You could do this by hand, but you're going to want to use the calculator. I'm going to hit Second Mode. I'm going to clear out the main screen, hit Stat one more time, go over to Calc and down to number 4 for me, which is line reg. Hit Enter twice. And there we go. So I have a negative, let's say 6.68x for my slope, and my B, I'll say 82.91. That's my line of best fit. So I go to y equals, I type that in. And when you hit graph, you'll be able to see both. And so you're starting about here at the 82. And we're heading down in between these two, kind of like this. And that's how I would get my line of best fit in my scatter plot. For 15 to, I believe, 19, we're going to go back to the PDF. For number 15, we just want to identify the slope and the y-intercept. That is all. And so my slope is right here at a negative 1/3. That does not want to highlight. And my y-intercept is the -1. We're going to use those in number 16, although we'll have different numbers to graph our line. Remember, you begin at B, which is the -2 on the y-axis, and then move according to the slope. Your numerator is your rise. So if it's a negative rise, you go down. And for your denominator, we're always going to run right. So we're going to go down 2, 1, 2, and then run right 3 and make another point. And then just connect this. And you can, of course, double check this by putting this into Y1 and hitting graph. 17, 18, 19. and 20 have to do with systems. The last two, we're going to look at system of equations using matrices. But for number 17, actually, I did move this back to the Smart Notebook so that we could have some more space. It says specifically use substitution. So the idea for substitution is that you're going to rewrite one of the equations where it says y equals or x equals, and then use that to sub out the y or the x for an expression. And so for this one, the second equation is going to be easy to solve for y. If I just subtract the negative 2x, and I'll have y equals a negative 2x plus 30. So now anywhere that I see a y in my first equation, I can take that y out and put in the negative 2x plus 30. And so instead of 5x plus 3 times y, that's going to be a negative 2x plus 30 equal to 80. Now solve for x. I have 5x minus 6x plus 90 equal to 80. And this very nicely turns into a negative x plus 90, which will subtract over to the other side for a negative 10, and x is 10. If x is 10, pick your favorite equation, which is now officially the one that I just rewrote. Plug that in. And you get that y is 10 also. And so my solution, where these two lines would intersect, is 10, 10. Number 18 says use elimination. The idea for that is that you're going to choose one of the variables that you want their coefficients to be opposites, so that when you kind of sandwich those equations together, that they'll add out. And so the easiest one, I think, to get rid of in number 18 is my y values, because if I multiply my first equation by a 2, that becomes a negative 4y, and my second equation has a positive 4y. So that when I add these two together, I get 11x, y's go, equal to a 34. I unfortunately have that x is equal to a I forgot to multiply by 2 there. That's much better, because now when I add, that will be a 33, which gives me x is 3. If x is 3, I can plug that into any of the equations that I found, even the new one, and solve for y. I'm going to go ahead and use this one right here, so that I get 4y is equal to 32, and so y is an 8. And so 3, 8 is where they intersect. 19 just says take your system that you see here in the augmented matrix and write the matching system of equations. So remember, first row is x's, second is y's. If there was a third, that would be z, like you see in number 20. After the bar are my solutions. And so my first line, my first row would be 9x plus 5y equal to a 9. And my second row would be a negative 4x plus 8y equal to an 8. And that would be the system. For 20, we want to go the exact other way. The remaining part of that sentence is if it has no solution, say that it's inconsistent. I did not give you any inconsistent systems on your test or in the practice. 3D systems are a lot of work by hand, so it's going to be a lot easier to create an augmented matrix. Right? Go the other way from 19 and use my calculator to put this in row-reduced echelon form. There is a way to do it by hand using row operations. It is a lot of work and takes up a lot of space. Once you have an augmented matrix, though, it's very easy to get into your calculator. Turn on your calculator. From the main screen, I'm going to clear that out. Go into Second Matrix. Go over to Edit. Click Enter on A. This is a 3 by 4. And now I just need to type in my rows. I'm going to double check my answer column. It's negative 7, 12, 10. Yeah. 1, negative 2, negative 1 for z, negative 2, 1, 1 for y, and then 3, 1, 3 for x. Very good. If it's good, you hit second enter, or second mode to go out to the main screen. Second matrix, over to math, down to RREF, row reduced echelon form. Remember, you need 2 R's. Hit enter, brings it to the main screen. Hit enter second matrix one more time and hit enter on A to call that out to the main screen. And when you hit enter a third time, there's your solution, as long as you have 1s on the diagonal. Remember, it needs to be 1s on the diagonal, 0 surrounding it, kind of like hugging in those 1s. My solution where these planes will intersect is at 1, 3, negative 4. X is 1, y is 3, z is negative 4, and there's your solution set. Your extra credit question will be on partial decomposition of fractions.